Hi there, my name is Brennan Crispin, and this is the visitor design pattern for CIS 566. So, to understand why we need the visitor pattern, let's give ourselves a scenario. So let's assume we have a collection. It could be a list, it could be a hash map, it could be a tree of employee objects. So we have an employee, which is our base class, and then we have engineer, manager, and designer that all inherit from employee. And you could imagine any number of other subclasses of employee, but for now we'll just say 3. So let's say that we have a toString method, but what happens later on? Maybe the string format changes. We have a new method that we need to create, or we have a toJSON method, or a toXML method, or several other pretty print methods, or say we need to add a new search method down the road. As you can imagine, like we're suddenly getting in each of these employee objects, and also in the base employee class, we're going to have a huge interface. We're going to have possibly dozens of methods required to implement this functionality. So there's a couple of solutions. Of course, the one like I just mentioned, we could add a new method to every single employee class. Of course, that comes to the question: what if we have dozens of operations? What if, for example, for our employee data structure, we might need to have several different output formats for different reports that we need to generate. That's going to pollute the interface and violate the single responsibility principle. Also, every single time we want to add a new operation, we have to hunt down every single class that we have and add that operation. And what if we want our employees to be behind a closed API? So we have our employees, and we put that out there for like other services in a company or to consume, but we don't want them to be able to modify our classes. So the other option is that you create a new object, a new class that can handle each new operation. And this is called the visitor pattern, and that's what we're going to talk about a little more. So the visitor pattern, as defined by the Gang of Four, is it represents an operation to be performed on elements of an object structure. Visitor lets you define a new operation without changing the classes of the element on which it operates. So with that definition, let's kind of dive in and see what that means in practice. So here you see the UML structure for the visitor pattern and for its elements. And there are going to be 5 core components to a visitor pattern. There is your abstract visitor, concrete visitors, which are going to inherit from the abstract visitor, an abstract element, which is going to have as part of its interface the accept method, and we'll talk about what that's all about. The concrete elements that you actually care about, and then the overall object structure, which might be its own class. It might be a list. It could also be a tree. And in the example that I provide, we actually use the visitor to traverse a tree structure in which each element has children elements. So in the visitor pattern, there are 2 major actors. There's the visitor, and the visitor has one requirement is visit, and it's going to have one visit method for each concrete element. And you'll see in the flowchart kind of how this interfaces with the element. And this is where the logic happens. So when visitor visit is called, the logic, and with the concrete element that it's visiting is passed in, the logic that you're doing, whether it's the printing, whether it's the searching, happens. And then the element is what you care about. And so they have required to have this method accept, which takes the visitor as an argument, and you have one accept method, which takes in an abstract visitor and calls visitor itself. So the flow for a visitor is you're going to have a collection or object structure called the accept method of the concrete element. So in this case, we have a composite. This is representative of what you'll be seeing in our demo. Then the concrete element calls, it actually calls visit on the visitor that is visiting it. It performs the operation using element A, which is passed in, and then it will then progress to the next element in the class. Oops. So the basic implementation of a visitor, so the element, you have an interface element which has a public accept method, and then your concrete elements will accept it. And when they receive the visitor as their parameter. They will call that visitor's visit method and pass themselves in so that the visitor can act on it. Then we look at the visitor. And so we're going to have an abstract visitor, which you don't see here, but it's going to have a list of virtual methods, visit methods for each element. And then within the concrete visitor, they're going to visit concrete element A, concrete element B, and so on. There are a couple of ways this is usually done. Either, as you can see here, we use overloading, or you can see back here is that in each concrete element, they will call so you would have in concrete element A, it would be v.visit concrete element A, concrete element B, v.visit concrete element B. And so then here in our in the client with the data structure, we're using just a list. So you have a list of elements, and it could be just elements of any varying types. You have concrete element visitor A, concrete visitor B, and they're going to do different things, whatever you want them to be. And then so in this case, we would, for element in elements, we're going to call element.visit and then element.visit. So when would you want to use a visitor? So one case is when there's a lot of operations that would need to be performed on objects, which you don't want to fill up their classes with methods. Especially this is true if you're expecting the object classes to rarely change, but you're expecting that you're going to want to perform operations on them, and they can be expected to change frequently. If you have a collection of many different objects with many different interfaces, and you want them to all interact with them in the same concrete way, so you would have them all implement your visitable interface. Or if you're building a public API with many data elements, and you want to allow users to operate on those elements but not change the classes. So the consequences of a visitor. The pros for the visitor is that it makes it really easy to add new operations and methods. You just create a new class, a new visitor class, you inherit visitor, and then for all of the elements you create something that will act on it. It allows you to collect related behavior into a single class rather than having to spread it across every object class. So if you do have a toJSON method, for example, you no longer have to go to each class and split that out. You can just have that all within one place. So when someone is looking at your code and they're like, oh, well, how is this JSON going to be formatted? Or how is this pretty print going to be formatted when I run it? You can see at a glance how every single object and class in your data structure is going to be formatted. And visitors can accumulate state, and you'll see an example of this. That is, it's possible for them to count the number of certain types of objects in a structure. The cons is it makes adding new elements harder. So anytime you want to add a new element, you're going to have to redo every single visitor that you have. And so as you saw, this is why visitors are usually better when your data structures are expected to be constant, but you are expecting to add new operations. Additionally, element interfaces need to be open enough for visitors, so that could break encapsulation. If everything in your elements are private and you don't want to provide getters and setters, for example, then the visitor is going to be limited in what it can do. And so if you're expecting to use visitors, you may have to have your data objects be more open than you otherwise want to. And double dispatch and the broken encapsulation, and we'll mention what double dispatch is, are sometimes considered to be code smells that make it harder to maintain and are considered less attractive. So double dispatch, it's just this concept, and in the visitor pattern, it's what allows you to simulate double dispatch in some languages. So a lot of languages, like the ones that we've worked with, like Java and C++, are called single dispatch languages. The method invoked depends on the signature of the receiving object. So if you have your list is list.add an element, the only method call, the overriding method call, is going to be the add signature for list. Double dispatch languages, for example, Smalltalk, the method invoked depends on the signature of both the calling and the receiving objects. And so since Java or C++ don't have double dispatch, we implement things like visitors in order to simulate that behavior. And it's nice because it does allow us to add operations to a class without actually changing that class. So a major related pattern is the iterator pattern, which also traverses a collection, but it operates on the collection elements in a different fashion. So For the sample that we are going to show, we have an element here. So we're going to look at something of a building management system, or building asset management system. So there's a lot of different elements that might be in this. We want to keep track of the building, the floors of the building, the rooms in the building, but then also we need to keep track of employees who are working in the rooms in that building, systems in the building, like you might say HVAC systems, for example, that might be attached to a floor or to a room, or might cover the entire building, as well as assets, such as, say, a computer, or or a cart, for example, that may be located in a room or assigned to a floor. So we're expecting that there's not going to be a whole lot of change in these data elements. There's not like that many different types of objects. And the data structure that we're going to have is going to be a tree structure or a composite structure. So a building is going to be composed of floors, a floor is going to be composed of rooms, and then rooms will have employees or will have assets, and floors will have building systems or rooms or assets. So we're going to need a way to traverse this data structure so that we can get information. And so we expect then that with all of these objects, we're going to want to be able to add different types of reports. We know what we're going to have, but down the road we have a few different methods. We have our visitor, and so it's going to, as you see, it's going to have separate different methods for each different element in the system. And so right now we're going to have a find by name visitor, which we can pass in a name. It's our search visitor. It'll travel through and check the name of each element and return a list of all elements matching that. A print visitor, which will just give us a simple pretty print of everything in the system, and then a value counter visitor, which will every single asset, employee, or building system has a price value, and so we can use this to traverse the tree and see how expensive things are. So to start with, here is the base element for our building management system, just element. As you can see, it has a virtual accept method that takes in a visitor. So all of everything that inherits from there, or extends it, is going to use that method. So for example, we have our asset. Asset has a few different elements. And when it accepts it, it calls the visitor.visit method and passes in itself. Similarly, building, and as you can see, because this is following some sort of tree structure, the building has as its part itself a list of floors, and then in the floors, so then in our accept method, it visits itself, and then it goes and calls the accept method on each floor element that it contains. Similarly, building system, it accepts, has a name. Employees can have assets, so as part of this tree structure. Once they've visited themselves, they're then going to call accept on all of the asset elements. Floors can have rooms and building systems. So in this case, they're going to visit themselves, or they're going to call the visitor and have the visitor visit themselves, and then they're going to iterate through all of the rooms that they contain and all of the building systems they contain and have them accept. Same thing with the floors. So from there, we look at our visitor. So the visitor, as you can see, because we have 6 different elements in this building system, it's going to have a different visit method for each of those elements. And as I said, in this case, we're using overloading to identify which one. So we just call the visit method on every element. And then the compiler will identify which actual visit method from whatever element is being passed in. We could also call this visit asset, visit building, visit employee. And then when we are in the building, the builder or the building or that element is responsible for calling the visit method that corresponds to itself. So in this case, it'd be visitor.visitBuilding. So for each of these then, we're going to have our visitors. So we have our print all visitor, which is going to, for each visit method, for each object, it's going to print out a description of that element. And so it's going to be different for each element that it could visit. Find by name visitor, because each element might have a different name that we want to search. So we might be searching for the room number In this case, we've been searching for a person's name in the case of the human. And so each one, when it gets visited, so when we visit an asset, it's going to see if the asset's type is equal to the search string, and if it does. And this find by name visitor is an example of an accumulator visitor. So it has a list, and as it travels through, it accumulates state. And in our client, I can show you how then that then is accessed. And finally, we have our value counter visitor. So only certain elements have values. So the ones that don't, they don't have any implementation. That's fine. It gets visited, nothing happens. The ones that do, and this is another accumulating visitor, those values of those assets, so we can tell how much things are worth in this building, are added to the value. So when we call main, at the beginning, we have an initialization of our building. So just for now, we're manually implementing it. We have employees, we have assets, and those are all just constructed into this tree and returned. And so at the beginning, we initialize our visitors. So we have a print all visitor, we initialize that. We have a value count visitor, which we'll initialize. And then we have a find by name visitor. And we're going to initialize a find by name visitor and set its search string to Bob. So you see we have an employee named Bob. So when this runs, it's going to search for that employee. So to call it, for each of these, we're going to office.accept. So that office element is going to accept it. And we could start at any point in the tree just by calling the accept method. So if we just cared about the value of objects on a floor, we would call that floor.accept the value counter visitor. But in this case, we're only worrying about the office.accept value counter visitor, office.accept find by name visitor. So first of all, so now this visitor contains the value of all of the elements in it. So we can call system.out.print total value, value counter visitor, get value. And then we can also do our find by name visitor, print found elements. And if we run this, it's building it. Okay, so first of all, it's just going to go through every element and print off a value. Then our total value visitor gets called, and we see the total value is 266,000. And finally, the print found elements, all it does is print off the name for that visitor, but we could do other things like return the element that we cared about. But right now it just prints off the name, and so it's Bob. It's pretty easily. So in conclusion, visitor pattern allows separation of algorithm logic from object structure. It enables adding virtual functions without modifying object code, requires both visitor and element abstract classes, and it's useful for large static number of element types. So here are the references, and thank you.